guys are meant to be living, not killing each other.
3, 2, 1. Stop!
We've got a group of lecturers and academics from Exeter University, led by Dr. James Cresswell, who's brought down a team. They're doing an activity based about natural selection and evolution to try and demonstrate selective pressures. So students are actually gathering different foods using different adaptations and appendages, and they're seeing which of those strategies is more effective.
There's another one.
Hi, I'm James Cresswell from School of Biosciences at the University of Exeter, and we're here at Thomas Hardy School today running a practical that we would normally run with our first year undergraduates, which involves turning them into predators and having them compete for food on an island. It's a practical that I developed if I was having to develop a new first year course, and I found it on the internet being run at a university in Canada, and I wrote to the staff there and they were very happy to send it here, and so we've given it a bit of a tweak, and we normally run it on a large and muddy playing field in spring with about 150 undergraduates scrabbling around in the mud with cutlery trying to eat corks and string and bits of foam.
Hi, I'm Katie Ball. I'm a first year PhD student at the University of Exeter, and I'm currently studying aquatic ecotoxicology, and I'm looking into the impact of nanoparticles in the environment, which is quite a big field, but it's relatively unknown, so it's quite exciting. I might find something or I might find absolutely nothing.
Hi, my name is Venera Pereira. I work as a bioinformatician doing my PhD in bioinformatics, looking at plant responses to localized and systemic stresses. The work they've been doing here is, you can look at it as a very good way to look at informatics, because you can put together data according to who died first and what kind of food substance we were mainly eaten quickly. So using that, you can look at graphs which can tell you if you remove a certain kind of food or you remove a certain kind of predator, then you're going to allow other predators or leave certain foods behind because the predator can't actually physically eat them. So informatics is mainly based on looking at what you can, I guess, forecast or predict what's going to happen.
And the whole idea of this was to show a group of Year 13 students a little bit about ecology. The idea was that there were 12 predators stuck on an island with various different food types. They had corks, straws, and bits of string and foam. And the idea is that they had feeding appendages around their necks, and they had to feed themselves, but they had a certain limit. They were only allowed 5 units. And if they ate too much, they'd explode. And if they didn't get enough food in the time limit of 45 seconds, then they'd die and they'd become extinct. Now, each predator had a different feeding appendage. They either were forks, knives or spoons, and obviously that confers different abilities to catch their prey.
There will be certain patterns which come across. So if you look at the 4 different islands they've got here, you can see that there's a couple of islands where the forks, the people with forks, the appendages, did kind of survive, whereas certain places you'd get certain artifacting where you had the spoons or the knives kind of evolving. That's mainly to do with people's ability to kind of then go, okay, so if I use a spoon this way, so you start looking at the different patterns arising in different areas, so you can then extract more information and try and develop an evolutionary model.
We're acting as predators with prey, and so we're using different eating implements like forks, spoons and knives to eat different food sources, which are sponges, straws, string and corks, and we're seeing which is the best competitor and which is like the most evolved, so it can eat all the food sources.
Yeah, and then in the second half of the afternoon we've had to change something so that we can change either a food source or how the predators actually are acting on the food, and seeing if that can make a difference to the evolutionary outcome.
This is your stomach basically, and you have to have 5 units inside. If you have over 5 units, your stomach explodes, or if you have less, you starve. So you have to have 5 units.
And you'll see behind us that they're all talking about which groups had, the best predators and which feeding appendage was the best one. They should find it was the forks or the spoons, but sometimes knives are good too if you're really good at stabbing things.
Okay, the general idea is that the students should be able to appreciate survival of the fittest, because evolution takes place over a very long time scale, this is a very shortened down version of evolution taking place, so they'll be able to see in a morning what happens over thousands of years in the environment.
So in this morning's sessions, the students were finding out which of the animal types on their island of knives, forks and spoons was the fittest under the particular conditions that we set out. And then this afternoon their job is to change the course of evolution by altering either the food on the island or the composition of the animal community on the island in some way, in order to try and make a different predator type the fittest. So the students will have to come up with a plan based on what they've observed this morning to change the course of evolution.
Okay, we've been explaining evolution in terms of an activity. So we've got all these foods here, and we've got different cutlery, and we have to pick them up in a certain amount of food and time, and those that don't get enough food in their stomach die out. And so we've just, at the moment, been changing different things to try and get rid of the forks, who are continuously winning.
Well, like now that it's obviously been around, you know, it was born 200 years ago, and it's like the evolution of species was published like 150 years ago, so now it's kind of taken this commonplace, whereas actually at the time it was really outrageous to say, particularly with like the religious implications it's holding. Although, like, personally, I think quite a lot of it is, we're obviously getting more and more evidence to show that it is really pretty much how it's happened, and what he said is actually still relevant 150 years on, and increasingly so now.
Right, I'm Mark McNair. I'm an evolutionary geneticist from Exeter University. I've been working in the field of evolution for the last 30 years, more than 30 years, and it's just such an exciting branch of science. Darwin is unique really amongst scientists in that his legacy has lasted so long. He published his seminal book 150 years ago, and it's still relevant. It makes sense, except in the light of evolution. If you don't have evolution, then everything else is stamp collecting. You know, why can you study E. coli, bacteria, or fungi and find out about medicine or other interesting bits of biology? The reason you can study bacteria and learn about humans is because we're all related, because we've basically got the same biochemistry and the same genes, and that the reason we have got the same genes is because of evolution, and therefore Darwin explains why biology is a science rather than a series of stamp collecting individual nature study.
Yeah, with technological advances, I think maybe more and more proof is coming to light all the time, which probably proves that Darwin's theory is correct. Although I don't think you can say anything is 100% certain, because science changes all the time. So I think it would be quite kind of narrow-minded to say it was 100% certain, but I think it is quite likely. Yeah.
And I think it can like come into play with religious. It doesn't have to be necessarily
one
or the other. And like actually, we were shown a quote from the end of The Origin of Species, and Darwin basically says exactly that. You know, this theory may be true, but it doesn't necessarily mean that religion is wrong.
It's just been really interesting to see how changing different variables alters like evolutionary history. So how different species become the dominant species when, say, you remove a food source or you remove competitors. And so it's just been really good to see how evolution really happened in action.